Let us then implement a hit or miss transform using the morphology from scikit image package. So remember that hit or miss transform is a kind of shape detection algorithm or pattern matching that uses the erosion as basis. So erosion can be seen as a hit or a matching, but only the erosion is not sufficient. So we are going to also erode the complement of A with a window object. Let us use this shape here as the shape we want to match in the image. So it's basically a rectangle with two small arms here. And we are going to define W as the window. So the window is basically the dilated version of S with a diamond. Okay, so I'm showing you here the image A, and on the right hand side my structuring element, so the shape that I want to match. Note that in this image here, the only two shapes that exactly match this object are on the left top side here and in the right bottom. Those other two are similar, but they don't match exactly. So we are going to first compute this term here. So A erosion with S. And note how the erosion tells us that there are similar elements in all four positions. However, we want to get rid of those that are not exactly matching. So let us compute the border of the window. So this is S, and then this is W minus S. So I want you to be sure that those shapes here are surrounded by black pixels. This is basically what we are going to do. That is why we are matching this with the complement of A. Okay, so this is the A complement. So we're trying to fit W minus S in this image here, the complement of A. That is we are going to do now. And note how it also had matches in other parts of the image, but the points that it matches were those two here, the exact points we want. And this is why we have to put everything together by taking the intersection. So basically is an AND operation. Everything that is inside this complement eroded here, and this A erosion with S. I'm going to use the binary or the bitwise AND that is implemented in Python. And in order to make sure that it works, we have to convert the matrices into binary. So in order to do that, I'm going to compare every point in A eroded with S, which is equal to 255, because here we are operating actually not in actual binary images, but images with values. White is 255 and black is 0. And every point in which we have also 255, it will become true, and the remaining will become false. I'm doing that because it is easier to work with, but if it is already in binary, we don't need to do that. And I think that's it. By doing AND between those two, we have the final hit or miss. And yeah, that's it. And note how those two images here were actually gray level images that I was treating as binary images, while the resulting image is actually a binary matrix in which one is the central the origin or the central part of the matching the patterns that we wanted. So that's it. This is the hit or miss transform, and as this example you can implement your own morphological operators using a combination of those already available building blocks that are erosion and dilation.